Hello folks, welcome to an unseasonably warm day for close to the end of February 2023, or at least I think it is. And I would also like to welcome you to the MuskVo project. But before we get into the details, let me warn you that this project and this video in particular promises to be exceedingly boring, long and uninformative. So do yourselves a favor, go up there to the search bar, type funny cats and press enter. And for heaven's sake, unsubscribe, dislike, and don't view the links in the description or support me, because if you support me, I'm going to do more of this kind of thing. This is what happens. You know, I take your hard-earned cash and buy junk with it, and then make crappy videos. Okay, the MuskVo project. What madness is this, and why do I find myself needing another vehicle? Well, I certainly don't. I've enough vehicle projects going on, but as happens in life, and a lot in my life, things rarely go to plan. And a couple of weeks ago, I was in bed, you know, kind of getting ready to sleep, and I started seeing pillars in my mind's eye, like, as in, you know, pillars like you might see in a kind of a concert hall or a church or something, like architectural sort of pillars. So why am I thinking about pillars? I sat up in bed and I see the 3D printer sitting there, and okay, pillars and a 3D printer. Why am I thinking about this? This is insane. Well, as a lot of you may know, for years now, I've had this kind of ongoing albatross project of various failed attempts at making a Tesla Model 3 drive unit function using open source means. And I'd came back to it a little bit there recently, and I think maybe some of that work I'd been doing on the new PCB had given me an idea. So I won't spoil what that idea is, because you're going to get to be bored, and we've got some very unexciting bench footage coming up for you. But let's not worry about that. The MuskVo. So one of the biggest challenges that I have, and I think a lot of people share, is motivation, right? You need to be motivated. You got to get up in the morning and think, I'm going to hack the Musk drive unit. I'm going to hack the Musk drive unit. And I kind of lack that a bit, right? But now, I am going to hack it. And it's going to work. But the internet is always doubtful. And that's good. It keeps me honest. The last time that I put a Tesla drive unit in a car with top spec camera work, I had some adult supervision from my friend Dave, and he was able to deal with things like accurate measurements and suspension geometries and all that kind of, I don't know, just weld it, just go. Grinder cut, MIG welded mild steel, right? And I don't have that adult supervision now. So if I attempted to put a Model 3 TH, see I'm doing the TH thing, okay? If I attempted to put a Model 3 drive unit into a BMW, which is rear wheel drive, I would make a mess out of it. And BMW do not make front wheel drive cars. No. I can hear you shouting at the screen. I can hear you. I got big ears. I can hear you. Let me repeat that. the kind of BMWs that you would want to drive are rear wheel drive. So I needed a front wheel drive car, because a front wheel drive car makes life very easy for installing a MuskVo drive unit, particularly when we're using OpenInverter, because we can run it full speed backwards. So enter the MuskVo. The MuskVo is a 2007 Volvo V50 estate car with a very noisy 1.8 litre petrol engine and just a tiny scratch on the passenger side wing. So I wasn't thinking about buying this car because I was just, I don't know, I was working away on the boring stuff on the bench. I happened to be scrolling a morning there a couple of days ago. The MuskVo. 500 bucks. Starts and drives about 90 miles away. What can you do? So I get on a bus and I go pick this thing up. And I drive it back here. It manages to get here. It's, you know, it's noisy and the exhaust is in 3 different parts, but we don't care about that. At the minute, we are involved in some CAN bus exploits here. Prior to the removal of this appendix. And we will then be transmogrifying the Model 3 rear drive unit in there with our first prototype modification to it. And this will be like the one that's currently in the Panzer, which is my first hand soldered LDU board. Let's just say that was a lot easier, even though there was a lot of surface mount parts on it. But this is the MuskVo project. Can't even remember the name of the damn thing. Anyway, MuskVo project. So I'll give you a little walk around the car. And then we will be, oh, is that my solder mask? My solder mask is arriving. Hang on. You know, folks, if I was a professional poo tuber, I'd be accused of having staged this, but conformal coating pen just arrived as I was speaking to you. Now, I have a new German word to butcher. Überzugstift grün. Überzugstift grün. Grün? It's not grün, it's grün. 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 Überzugstift grün. I've been practicing my umlauts. So, we are going to have to skip the walk around because I need to get the old Überzugstift grün and start doing the boring bit on the bench. Stay with us. All right then, I suppose I might as well, seeing as I'm here, before we go at the Überzugstift grün. Here it is, some kind of engine type thing. I removed the old airbox here and have tapped into the CAN bus and put my little CAN analyzer thing in a IP65 high impact enclosure. We've also been doing some jacking the car up, that is. And here you can see there's just a tiny scratch. I mean, you can barely see it, right? You can barely see that. And I'm sure that'll buff straight out. But the rest of the vehicle is, strangely enough, pretty straight for a MuskVo. It's weirdly short compared to the to the goose. Like it's kind of, it seems shorter at the back. I don't know. But anyway, there it is. It does have heated seats, so I quite like that part. And the dash is kind of interesting, but we'll do more on this at a later stage. Right now, Überzugstift Grün awaits us. Recording. So is this thing on? I do not know. What I do know is this is attempt number 1 with our new modboard system. So we have removed the TI part, and as I say, if you want to know how I did that, did that actually years ago now, so there'll be a video of that in the playlist, and I'll see if I can put a link in the description. So now that we've our chip removed, as you can see here, this is the same board I was using from years back, because when I removed the first part, I damaged these 2 tracks here, or pads here, but they're brought out to these vias here, so we should be able to get a connection. But anyway, yeah, this is going to be attempt number 1. So with our 3D printed part, so I'm just going to use a scalpel just to remove a little bit of crap just from on the back of it. We have the back of the printed part. There's the countersunk hole. Unfortunately, it just got a little bit of junk in it, or stringing, or whatever. PET tends to do that. Now, so the first thing that we need to do is bring our center pad of our processor under the microscope. And we'll start recording. Okay, we're recording again. Let me just make my old preview on this. Oops, wrong one. There it is. Alright, so did a little bit of hacking on my 3D printed part with a scalpel. So now we've got, got very good line up on this pad, and I got very good line up on these pads here, just as I move the board like that. So I'll just pop the board off, and you can see what I had to do. Okay. So obviously I'll be changing the printed part to have the track in a slightly different way, but you can see there that the positioning where I had the track going over to here was just in the wrong spot, and it kind of needs to be. So I don't really like the way that piece of resistor leg was working for me. Looked like something that would just love to break off. So I'm going to try something else. I'm going to try a little bit of stranded wire. Okay, so slightly different print. I've increased the size of the slot for the ground wire. And in the back then, got a much larger recess area for the center pad. So let's see how badly I've screwed this up. Now what we don't want, the disadvantage of using stranded wire, of course, we don't want any stray strands. That one, for example. Oh yeah, okay, that works. Yeah. Alright, that's not rocking around the Christmas tree at all now. definitely a lot more solid. So it looks like doing that recess on the bottom solved that problem. Got a very nice, got that very nicely in there. I don't know if you can really see much with the microscope, but yeah, we can actually. Just need to recenter it a little bit better. See, ultimately that's going to be glued down. But before we do anything like that, we have other projects, other parts of the procedure. So we have that just sitting there, not glued down or anything. Let me go ahead and thread the little wire up here into our motherboard, into our ground situation here. Everything just wants to be not where I want it to be, of course, but again, when that's glued down, hoping life will be a little bit better for everyone. Now there's my pin there, you can see that one. He wants to go there, so he wants to go there, and then it'll be about, oh yeah. Okay, so we're a little bit in closer. There'll be a lot of shine on the board, unfortunately. But anyway, that's, yeah, that's a lot better with the part there than where we were before. So you'll see, like I say, I'm just kind of roughly positioning it, but there's no more of this kind of rocking here. Yeah, there's none at all in that now. You can even see that on the microscope. Rocking my finger around on that, there's no you know, it just doesn't really want to go anywhere. When that's glued on, and we're going to be all set. So before we can do that part, we have to start attaching our, I guess we call them bond wires, because we're kind of well, I don't know, we're probably not really down to gold bonds, but we're down to pretty small stuff. So, all right, happy enough with our motherboard and our little 3D printed part now. These two guys here seem to be doing the job for me. What the procedure now is, that we really want to be starting to solder the first of our wires onto the pads here. All right, so let's see what life's going to bring us here. Not 100% sure, because I've got my microscope stand kind of spread out a little bit now, so it mightn't be as stable as the last time. Hopefully it will be. Right, so we need the first 5. Basically we need pins 1 to 5 here. They're going to be our first kind of clients in this situation. Using some thin solder. I'm just going to put a little very light. Oops, I managed to kill that pad. Well, I'd rather have it removed. Rather have a dead pad. Yeah, that's the last of that pad that's going to annoy us anyway. But the good news is there's a via in there that we'll be able to get onto. So that's the bad news. Like I say, this board's kind of a worst case scenario because it had quite a few, you know, it's had a lot of poking done on it, let's put it that way. Yeah, I don't know if I like that wire. But I'm really sure I'm on the 0.2 stuff, because I know I got 0.3 as well. Just might triple check that. Pretty sure this is the 0.2 though. Alright, well let's start here and see what life brings us. Because there's obviously, we can see here, we've got, that's pin 1, so it's on that via as well. And there's a via behind it. Well, yeah, I mean, that one, I'd actually picked up the solder, not the wire. That's why it was looking so big. I was like, what the hell? There we go. That's better. Oh, that's okay. Now I feel a little better. All right. There we go. All right. The key to doing this is going to be just patience and time. Not trying to win all the battles every day, because we won't win them. Not going to win them. And we only make ourselves you know, frustrated. You're going to want to give up on it and all that kind of thing. So it's going to be a slow, kind of a steady process rather than big kind of, you know, gains in one day sort of a thing. We're not going to have big gains in one day. Which is why having the MuskVo outside, I think, is going to be a big help to me, because once I get tired of kind of doing micro soldering like this, well, we can go play with the MuskVo. Now, there's number 1 on. So each wire that I'm attaching here, what I'm going to do is I'm going to leave it hanging back here, and I'm going to snip it off. Like so. So that's wire number 1 on. Now wire number 1's easy because it's a corner pad, right? So that's basically the first wire attached. So I'm going to just move him over like that. Now I'm not going to film all of this, because, you know, it would absolutely drive folks nuts, and I, you know, can't say I blame you very much for that if you did get driven nuts. Give that a little bit of juice there. Not quite going for the whole, you know, the right amount of flux kind of thing here, but we'll definitely try. There you go, Elon. Let's see if we can get you on there as well. Oh yeah. Elon J. Musk. Now the good news that we have here as well is that because we've all of these lovely vias going around the device, we don't necessarily always have to use the pad, right? Because we've got choices here. We've got choices, right? We can use these vias to our own advantage. Now the MuskVo is kind of blocking me a little bit there, but I'm managing to kind of burn it away. I'm rather surprised with how good this little microscope is now with the with the 3D printed stand. The stand that comes with those things is worse than a joke. It's terrible. Well, this one at least gives me an arm. You know, it's not a, like I said, it's not a Lewis job, but it's definitely, let's see now, I'm going to bend that around a little bit. It's definitely better than the ones that they supply. Now that looks good. This may seem masochistic of me, but I'm starting to enjoy this. Because it's not going to be, you know, like I said, it's not going to be, you know, you solder it on in, you know, 2 hours or something. Well, maybe there's people that can. I'm sure there probably are. Oh yeah. You know, this is my first foray into this particular arena. You know, going down the wire. Literally, the wire is this kind of thickness. Now, obviously, what's going to happen here, and you know, we've got to be aware of this, is that we are going to touch wires together here, particularly in this area. Now, I'm not hugely worried about that because obviously when we tease these out and we bring them into the mod board, they'll be a lot straighter and we'll be able to see, thanks to the microscope, any shorts, and any shorts we have we can physically separate. And then we'll also be putting a thing of conformal coating on this. So my plan for today, at least for this segment anyway, it's going to be to get, let me see, I'm going to just rotate this ever so. All right, here we go again. Day 2. So we are currently up to pin 12. That's the last one that you see soldered there on our TI pinout. Now, just to remind everyone, we don't have to solder all the pins. So in fact, these next two here we're going to skip. And then, so it's the next one down is a VDD pin, which is one of our 3v3 pins here. So I'm going to put a little bit of flux around here. It's a little blob. And we'll get a little bit of solder going. So the interesting thing, if you want to call it that, well, any of this interesting, can't think how you would be, but interesting thing is the more I'm doing of this, the more I'm kind of seeing other options for the mod board. And the big problem that I had previously was the hole spacing. So I'm going to skip those two. Here he comes. Open wide, Elon. Ooh, that's a big piece. We don't want all that in there. Time for lunch, Mr. Musk. Ooh, we do not want a short circuit in there. There we go. because that pin there I've just soldered onto, that's a 3V3 pin, and the one beside it is a 1V2, because the TI chip uses 1V2 for core and 3V3 for I/O, whereas we don't need any of that. So then we have, so let's see here, then we have, so that's a space of 2, then we have another space of 2, now we're into PWMA high. Is it PWMA high? Yes, it is PWMA high, which would be pin 18, yeah, pin 18 on our TI. So basically what we have is we have VDD then on that next pin, then we have another pin we want to skip, and then we have, yeah, PWMA high and PWMA low. Now, advantage is this one here, yeah, this one here is PWMA high, pin 18. And this one beside him, his friend, I'm going to clean my soldering iron bit. I really like the little hook-shaped bit for doing this work. Yeah, so that's my 1V2. That's the one we're not connecting to. Yeah, here we go. Still have to burn away quite a bit of that conformal coating. I can kind of feel it there. There we go. Now we're getting down through it. There it is. Look at that. Whoops. Tap that. Mr. Musk would not be happy with that. Now, so once again, this would be pin, yeah, this is pin 18. So I'm going to see if I can connect to the, in this case, I'm going to see, let me just rotate my board a little bit here, myself, a little bit more workability here. Going for the most boring video that I've ever made, by the way. So I know that's a bit of a challenge, because I have made some very boring videos over the years. I think this one is going to be the best one. Ooh, yeah, see a little bit of strain built up on that wire. It's the key thing when you're doing wire this thin is to make sure that wherever you're trying to solder it, it's where it wants to stay. Of course, always easier said than done, like a lot of this work. There we are. Look at that. Alright, so that's pin 18, PWMA high. No fun if I'm not doing to. Oh! Got a little bit of heat in the wrong spot there now because we have these two close together, but there we go. I think we've pulled it back. I don't think we've gone on to the other pad there. I'm pretty sure we haven't. I'm pretty sure we haven't. But I might just need to be a little bit more sure than that, to be honest. Yeah, I don't think we have. I think we're okay. Ah, there it is. Now we certainly haven't. No, we certainly haven't. And snip. Alright. That's old CP procs. Now we gotta skip 2. So basically then, yeah, we gotta skip 2. So we should have VDDIO. We've got VDDIO. We've got break NC. And CP procs. That's the one I've just soldered there. Okay, so I figured out my pinouts. I had a few pads I don't actually need on the little PCB. little friend here. So that one that I just soldered onto there now is actually pin 39 on our TI part, and that is the current sensor for phase A. So that guy is pretty good. He's not fully on the pad, as you can probably see there. But, oh, yeah, that's what I get for. But he's in pretty good shape. I don't think he's gonna, I don't think he's gonna cause us any problems there. So I think we can safely snip him off and call him done. Now his friend beside him here, pin 40, is our throttle channel 2. So we got to get a little bit of flux on here, just because we're going to have two in pretty close proximity, folks. Oh, you're probably very excited about all this. I'm very excited about it as well. Sure, Elon's equally excited. Oops, haha, look at that. I actually managed to get it in a better position. Alright, well, let's see if we can burn ourselves a hole in this conformal coating, which we have done. Alright, we are on. Okay, folks, welcome to the final side of our wire laying. So it's just been pretty much as you saw earlier, just laying down the wires here, laying them flat out and cleaning up everything. Now this isn't the way we're going to be doing it for hopefully which will be the release version of this thing. This is kind of a first version, and I suppose it's kind of typical with me. I always end up having multiple variants of the thing. Let me see if my tweezers is a bit better. Yes, I think it is. Okay, right. So I'm going to lay some of these wires. I'll bring you along for one or two, and then we'll cut back when we have them all laid on here and we've cleaned up again with a bit of IPA. So this corner pad here that you're looking at is pin number 133. So we won't be connecting to pin 133. We've got to skip 1, 2, 3, 4, and 5, and then we want to go on to 6. So the 6th pin in here is in fact a VDD pin, so our 3v3 supply again. Not sure if I really need to be grabbing, you know, all of these VDD IOs, but I'm doing it anyway. Here, let's put a little blob on here. And yeah, so we're looking for the, let's go again, 1, 2, 3, 4, 5, and 6. The 6th pin in from this end is a VDD, which is a 3v3. Okay. So let's see. Unfortunately, my little 3D printed microscope stand is not exactly super steady. So whenever I talk, even that, just sound waves and the air from my mouth just moves the microscope. So I'm going to shut up and do some wiring. Okay, so I don't know how long this thing is going to stay working. My Windows laptop here is on its last limbs, unfortunately. It's dropping out the USB to the webcam and the microscope, of course, right when I'm in the middle of trying to solder something. But anyway, I do have another laptop here that has a cracked screen, but the problem with that is it's HDMI output, and of course the silly monitor I have here is, well, what you call it, DVI thing. So of course, yeah, compatibility. Gonna have to get another monitor as HDMI, or I might try and get a TV or something that'll be just bigger here, so it might be useful in more ways than one. So I'll figure that out. Hopefully it'll stay working long enough now for us to get some of these wires laid out. So alright, so this is side 4. So we have came in here 1, 2, 3, 1, 2, 3, 4, and we hit 5. So 1, 2, 3, 1, 2, 3, 4, 5, which would be wrong actually. That would be wrong. That'd be a VDD pin. Ah, 1, 2, 3. No, sorry, 1, 2, 3, 4, 5, 6. Oh no, sorry, we hit 6. That's right. That's VDDIO. And the one beside it then is our red LED. And then we had to skip 1, 2, 3, 4, 5, and hit 6. So 1, 2, 3, 4, 5. Yeah, then we hit 6, and that's our 74245 enable line there, which is our gate driver. Signals to the gate driver go through a 74245. Then we have a skip, then we have a VDDIO, so we have that one. Then we have a skip 2, and we have the enable for the power supply for gate driving. So that's our last wire we have on there. There he is. Let's push him up there a bit. So now we have him on, so we now want to go skip 1 and hit the next one, because that one there then would be a VDD IO. For some strange reason I might I might skip that one, because I'm not sure I need to have that on there. Yeah, because there's a VDD. I have to check my pinouts here on this just to be sure, because according to my diagram here, it's a little bit older than the latest pinout that we have. Pin, I think 157 is the VDDIO, and 158 is the VDD. And oh no, I'm wrong. I'm completely wrong. Here we go. Sorry. So pin 151 VDDIO. So according to that, yeah, I'd skip 1 and then I'd have VDDIO, which is, I think that's backwards. I need to double check my pinouts. I think I have a little bit of a screw up there. So if you look at those 2 pins there, which have the vias going on the inside of the layout, those are 3v3 and 1v2 supplies, but I don't know which is which at the minute. So what I'm going to do is I'm going to skip both of them, and I'm going to go to the next pin there. So I'm going to go 1, 2, 3, and then I'm going to hit that one. That'll be our green LED. So if I skip both of those, and we just go on to this pad here, that pad there should be our green LED. So this one here is pin 3. So it's this one. So that's got to be 3v3. Yeah. Yeah. So that is pin 168. So if that's pin 168 here, then it's 169, 170, 171, 172, 173, 174, 175, 176. So that one there would be pin 176 on that cord. Alright, I've given it a good clean with IPA. So let's have a quick little skim around here just to see if anything weird kind of jumps out at me. Alright, back over this way. These are our damaged ones here from day 1. So you'll see there we've some, like, those ones are very close, so we'll be obviously doing some solder masking there. yeah, they generally worked out well. I've had several cleanings now. Several cleanings. So you know, not brilliant in some areas, but I think good enough for getting us up and running. So I'm gonna, that should be pretty dried off by now, to be honest. Let's just grab the printed part for a second. I'm gonna stop. I'm gonna zoom the microscope back out a bit so I'll be able to see a bit more, hopefully. I'll see about getting the little printed part put on here then. Alright, so figured might as well torture you. You know, if I'm going to be tortured, you guys might as well be tortured. So I mixed up a teeny tiny little bit of epoxy. I'm just gonna just dab it around the kind of uncovered area here, just where we'd be. Just want to put a few little blobs here. This is a 2-hour epoxy, so there's, oh, that's way too much. Yep. Congratulations, Damien. Already put on too much of it. So there we go. These are just little dabs. Even then I've got to be cautious of putting on too much. There we go. On our little 3D printed part, just to be kind of a secure base for nations. Okay, let's see what that does for us. So we take our printed part. I think there might be a way to replace the printed part with a kind of an intermediate PCB as well. I'm kind of had a thought about that last night before going to sleep. Oops. Would avoid this kind of messing about, because obviously what we're doing here is not a practical solution for people to use. So we're going to be looking at ways of making it more user-friendly. Ah, there we are. Got it. Alright. There we go. Now let's straighten this guy up as best we can. Alright, might as well record this, because if I'm going to screw up again, might as well know why. So this is my little overcoat pen thing. Flux, not flux pen, what do they call it? Conformal coating pen? Yeah, I guess so. Oh, okay. Oh, there it is, okay. Let's see how this plays out then. Oh yeah. Oh, me likes that. Oh, me likes that a lot. There we are. Oh, nearly there. And there's just one up here. Oops. Yeah, better not be moving that guy too much. Now, there we are. I think when I get done with this, I'm going to go and annoy the MuskVo some more. Because it's apparently these MuskVos, these, I don't know what you call it, an immobilizer. That's impossible to get rid of. So that sounds like something I don't really want to do. I'll probably do it just to make life hard for myself, because I mean, it's not like I'm, you know, life's not hard enough doing all this, but just was that these pads are too close together. So of course, genius here didn't realize that what I can do is I can stagger them. So I can say that pad in that position, but this pad here can stagger backwards a ½ millimeter. And that gives me enough clearance to get up to 0.4 millimeter holes, so twice the hole size that we have here. And that then should allow us, theoretically at least, to go back to plan A and be able to drop the wires down through the holes here directly onto the pad, so none of this laying out the wires as we've been doing here. But that will be subsequent to us having some success here with this kind of very labor intensive version. So okay, I'm going to let that solder mask go off a bit, and then what I'm actually going to do is I'm going to glue down the mod board here, because then when we come back tomorrow, this will be all solid, and we can actually start dropping the wires onto the mod board. So that's the plan. Alrighty, I won't bother showing you me gluing down the board. It's just mixing a little bit of epoxy, dabbing it on, and dropping the board down on there. So that's it for today. Well, folks, hard to believe, but welcome to day 5. Our mudboard and spacer are glued on, and I've just got started here now this morning, bringing, we'll call them, for want of a better word, the bond wires up from the main board up to the mudboard. Now you can see straight away here, my original plan had been to use the holes in the board there, excuse me, to bring the bond wires down through. But because I'm stupid, I put all the holes in a row. Whereas if I'd staggered them, as you'll see on the KiCad layout soon, I'd be able to have larger holes and be able to push the wires down through them onto the pads underneath, which would be the original plan. Now, you know, that's kind of the way these things work out, at least for me anyway. So we've got our first 5 wires connected, and as you can see, it is a little bit of a challenge because, you know, again, being stupid, having the pads in a row, but they are going on. Now it's a mess of flux at the minute, but we'll show you a cleaner shot once we get that flux cleaned up. But I'm happy to say my solder mask worked great, and the leads are really well held down there onto the main board. I've done a little just multimeter check, making sure there's nothing stupid on the mod board, and there's not. We've got ground and 3v3 on the mod board now, coming up from the main board. So the connections you see there are basically the C, PWM, high and low, 3v3 in the middle, and the B side, or the B phase PWMs there. So the next thing that we're going to do now is we're going to tin this next batch here, which is a batch of 6 lines. And I'll just go ahead and do that. And I'll do 1 or 2 of these on camera here for you. But this is going to be a procedure that'll take a couple of days now, realistically. So I'm not going to subject you all to that, obviously. Because I like you all too much. So what I'm doing, just as an absolute, because I'm just taking each wire, you know, crazy individually, going back over my pinouts here and all this. So it is a very slow process. But as I say, hopefully now we're going to be speeding that up. So what we should have is, there's our PWMBs. Then we should have a skip, and we should we're skipping pin 6, which is, I don't know what pin 6 is, but we're not using it anyway. And then we should have brake normally open. What I'm doing here is I'm having to use my little hand magnifier and just get my head down here and just get in here and just see, yeah, there's my skipped pin, and then this guy here is my brake and all. So yeah, I'm just been very painstaking with it. It is the first prototype, so nature of the beast, folks. There we go. There's our little friend. There he is. So that's our first wire there now. Let's bring him up. Bring him in under the microscope. The microscope is kind of struggling a little bit here because of the fact that there's 2 boards, I mean, with the 3mm spacer in there. So it is causing it a little bit of a struggle to focus. So I'm going to shut up now, because literally if I speak near the damn thing, it starts to vibrate. There we go. So that's brake NO connected. And I'm using my smallest snips, which is going to look like jaws when I bring it in here now. Pretty much looks like a bolt cutter when you bring it in under the microscope. And again, I'm just, you know, the total methodical approach here. Alrighty, so we are just over halfway home. We have the entirety of, I guess we'll call this side 1 here done, and the entirety of side 2 done. I just started on side 3 here, but I started kind of feeling a little bit tired, and I also came across one mistake on one of these wires here, that I have it just on the wrong pad, so it's basically 1 pad out. So I will have to just change that tomorrow. But yeah, it's turning out really good. As I said, even for a worst case scenario, which is this kind of a design whereby the pads are that small and they're that close together, it's still feasible. So I think the next variant where we have the pads staggered and they have the holes in them, I think will work much nicer. Those are just some unused pads there. And then we come around. Okay, folks, I'm sure at this point you're well and truly tired looking at all of this stuff. I thought we would give you a little bit of a rest. So if we backtrack over here onto side 3, which I've finished. So down here at this end we were fine at this corner, so the corner between side 2 and side 3. So we've got our LIN. So we've got here's our LIN bus for the oil pump. So that's a LIN, that's a power, that's a LIN. And then we've our 4 gate SPI connections, so our MISO, MOSI, clock, and chip select. Then I had a bit of a problem because I'd actually attached some of my lead wires here to wrong places for the gate driver fault output, and also this guy here. Sorry, that one is the gate driver fault, and that one is the interrupt pin from the main power supply chip on our board, which is over here. So I had turned out in my, I guess, haste or whatever, even though I was triple checking, I had made a mistake and put these 2 bond wires, let's call them anyway, on the wrong pad. So I had to kind of backtrack a little bit here. It took me a little bit more time. So a minute now, we're finished that side. We're on to side 4. So we've got some LEDs, some power. Another interesting one here is probably this guy, which is the output enable for the 74245, which lets us send our gate drive signals to the actual gate drivers. So there's some more LEDs, and now I'm over here. That one's that one there is our green LED. We've got 2 LEDs. We've got a green LED there. And now I'm up to these 2 pads here, and basically what we've got is we have got power, so our 3v3 on this pad here, and then this guy here is our exciter, basically the output to the exciter amplifier. So those are the ones I'm going to be doing next. And then finally we have 4 wires for our 2 CAN channels, and the last one here then is this pad here, which is a 3v3. So I'm going to go ahead and do these off camera. No need to torture you folks with that, and we'll come back then just when we're doing the last one here. Okay, so we're down to our last 3. So we have our first CAN bus on. This is our next CAN bus. Coming over, come on. Come on, Mr. CAN bus. Come over this way. Oh, they were not snipped off though. Just gonna tin him a little bit there. I don't know if I put too much on. Possibly did. Oh, we're okay. There we go. That's it, folks. Last one. The last one. Last wire connected. Yeah, that's it. I'm going to go ahead and just go around them with the little viewer, and then we'll give everything a clean up with some IPA. We'll come back and give you a little tour then of the finished motherboard. Alright, so just done a first bit of an IPA cleanup there. So it's actually turned out pretty darn neat. That's our big ground connection there. She turned out pretty neat. Still a bit of flux residue there, but we'll get that off before we seal in the wires. But we're definitely very near being able to do initial power up testing. Okay, folks. Day 7. As you can probably tell by the flashing LED here, the STM32 is powered up, it is programmed, and it is executing the OpenInverter FOC firmware. I've got a hacked up JTAG board here just to give me access to the JTAG header on the Model 3 drive unit mainboard to let me connect my Wi-Fi module here, because what I did was when I was designing the board, I used the JTAG header here for the SWD programming for the STM32 and the UART for the Wi-Fi. So I've just got one of my JTAG boards, just cut a chunk out of it so it'd fit in there, but that breaks out the it breaks out all of the pins here. Apart from doing the whole TI JTAG thing, it breaks out these pins onto a standard 2.5mm header. So that lets me then connect my Wi-Fi. So obviously, one of my first priorities now, when I order the new variant of this mod board, will be to design a little header board that'll just plug in here and carry the Wi-Fi module and just break out my SW programming. Now, again, for actual use, you won't need any of this junk here. This is just for testing and development. Johannes and some of the folks over on the OpenInverter forum are working on a CAN-based Wi-Fi adapter. So therefore there'll be no need to have these modules inside the drive units or enclosures and all. That can be connected anywhere in the vehicle that you have your CAN bus. So yeah, I'm kind of a little bit deflated at the minute. This has been just it's not just been the last 7 days, it's been years now trying to work out a way to do this in a way that actually works, and it does. Now we've got a lot of further work to do here. I'll be putting the current sensors back in, because if I just pan you around there, you'll see I have probably seen it anyway for the last couple of days and so on, but you'll see I have the current sensors removed from the board here. So one thing that folks might find interesting, just while we're here, is having a look at the current sensors, because I don't think there's much information out there about them. The current sensors are very similar to those used in the Model S small drive unit, and these are these fellows. These are made by Melexis. The part number is MLX91209CA, as you can see there. So these guys are a little Hall effect sensor that basically work in conjunction with this, with one of these little kind of, I don't know what you'd call them, these kind of housings which have a ring, kind of a ferrite ring in there, and there's a little space where the where the current sensor fits down into some MuskVo, of course. So yeah, that's your Model 3 drive unit current sensor. Not much to see there. There's just power, ground, output. I think a reference pin that they use for some calibration and programming, I think, as well. Because I've been just doing some testing and analyses on them for the replacement board design project. So I'm going to pop those current sensors back in, but you won't see that till the next episode because this thing is probably hours long at this stage. Also worth noting that just on this very crude variant here, we have communication with the TLF power supply chip here. This guy that does all the low voltage power supply. The gate driver is currently punched up. If we go to DC voltage, go onto one of our transistors here. As if I can get a connection. That MuskVo is just unreal. He secretes it onto almost every surface. Yeah, -5 volts, which is our default off state for our SiC FETs. So we got a lot of work here to do still before we'll be spinning motors, but by the same token, that's a huge milestone for us here now. So I got to work out. I'm going to have to draw on some of Johannes's knowledge to work out some of the pin out stuff here, but for things like the PWM pin assignments and the resolver exciter and so on, and there'll probably be sillies in here that I'll have misconnected and things like that. So we got a good bit of work to do here, but by the same token, we are very much now on track to not only been able, for this drive unit board to go back in an inverter and run a drive unit, but also to have a solution for this that basically means we don't need to spend 7 days doing micro soldering. So folks, I'm going to wrap this up here. I don't think I can kind of do much more anyway. I'm not going to fit the current sensors today or in this episode because I want to leave them off for a while just so I can simulate them here with a power supply and resistors and stuff, just to make sure we have signals getting to our microcontroller and stuff like that. So yeah, we got a lot of little additions to put into the code because we need to drive we need SPI for the power supply, we need SPI for the gate drivers, we need the multiplexer driver for the temperature sensors, and just get the pin out sorted. But it's not even from my non-existent programming skills, I'd probably hack my way through it over another year, but probably take Johannes 10 minutes. So anyway, yeah, I'm not making much sense now at this stage. I'll leave it there. We will see you in the next semi-exciting but also potentially boring episode. As always, particularly with this kind of stuff, give us the old thumbs down. Do not share. Do not subscribe. In fact, unsubscribe. Hit that unsubscribe button. And yeah, do not either check the links in the description because they're all boring, and whatever you do, don't check the ones down there for Patreon and PayPal. The last thing I need now is more financial support, because then you will see things like this happening. So that's it, folks. I'm going to sign out, and until next time, happy FOC firmware modification.